In today's video, we are going to talk about the law of sines. So here is the law of sines. Okay, it is sine of an angle over the opposite side. So sine of angle A over side A should equal, it's proportional to the other sets as well. So sine of B over B, sine of angle C over side C. So just any two of those are going to be equal to each other depending on what you have in your problem. You can actually also flip these. So if you wanted to put side A on top and then sine of angle A on bottom, you could definitely do that. Equal to side C over sine of angle C. Okay, so you can flip them over or you can leave them with the sine on top and the side on bottom. It's just going to be personal preference, kind of how you like to set it up. So when is it appropriate to use law of sines? So law of sines is appropriate to use as long as you have angle side, so two angles and the side not included between those angles. Remember, this was a way to prove triangles congruent in geometry. Okay, this one as well. And then this one is going to be kind of special. So if you have two angles and the side not between those two angles, okay? So if you have a triangle and the information that is given to you in the problem is the measure of this angle, and then they also give you a length for this side, okay? This is an appropriate time to use law of sines, okay? The problem could also give you two angles and the side between them. Okay, so if you had this angle given to you, this angle given to you, and this side, so between those two angles, appropriate to use law of sines. Okay, so anytime really that you have two angles, it's appropriate to use law of sines. So now this third case, if you remember when you were learning about proving triangles congruent in geometry, remember that ASS or SSA was not a way that you could prove triangles were congruent. The only time that this worked was when the angle was a 90-degree angle. Okay, so if we had a right triangle, then we called it hypotenuse leg. So if you recall, this actually gave two different triangles. So if I gave you two side lengths and the non-included angle, you could make a different triangle than somebody else with the same measurements, okay? So taking a look here, so if I'm giving you two sides here, okay, so I've given you this red length side and then this side and then this angle. You can actually create these two triangles with those same exact measures. So let me just kind of show you that. So this length, and this length, that gives you a triangle, right? Okay, so we've got this. Let me see if I can grab that. Okay, so here's one triangle. Okay, so that's one of the ones that could be created. And now, again, if I leave, this length the same, okay, this is the same length as this one that I used earlier, and this is keeping this angle. Okay, so this still has this angle measure, this side length, and this is a totally different triangle. See if I can grab this. Oops. Okay, let's do it like this. Let me get rid of that. But so then you get this triangle, and that is a totally different triangle than this one, even though it has the same given measurements. It gives you this angle, this side, and this side. This side is congruent to this one. This side is congruent to this one. And then this angle stayed the same, right? So two totally different triangles, okay? So in law of sines, this is called the ambiguous case when you have angle side side or side side angle, okay? There is potentially going to be zero triangles, like the information given to you won't work, or there could be only one triangle with that measure, or you could end up with two answers, okay? So this one becomes quite a bit more complicated, okay? So this is the ambiguous case. And we'll talk about how you decide if there's no triangles, one or two, okay? But the thing that you need to remember is this is when you have two sides and the angle not between it. So if you get information like this, that when you draw your triangle, you are given, this side, and an angle not between it. So something like this. remember that if you had the angle between, side angle side, that would be a use of law of cosines. All right, so let's take a look at some examples here. So given side H is 980, so side H is across from angle H, so 980 inches here. Angle H is 114 degrees, and angle F is 48 degrees. Let's find the length of side F to the nearest tenth of an inch, okay? So this is what we are looking for over here. So I'm going to write this information. So I've got 114, whoops, that is a side length, not an angle measure. No, that's an angle measure. What am I talking about? Okay, so 114, 48 degrees, and then 980 for this one. Okay, so again, take a look, see what you have. So you're given two angles. Okay, so I've got two angles, and then the side that is not between them. So this is an angle side case. So law of sines is going to be appropriate here. And so remember that you do the side paired with the sine of that angle. So here's where I said, I'm going to actually put this on top, okay? So we're looking for a side length. I'm going to put the side on top because I like my variable to just like be on the top. I don't want it on the bottom. So I'm going to do F over sine of F. Okay, and then we are given paired up side H with angle H. Okay, so I'm going to do H on top here over sine of H here. Okay, so the side that I'm looking for paired with its angle, the side that I'm given paired with its angle. Then you can just fill in your information. So we're looking for F, that's our variable. If you want to put an X there, you can. Over sine of 48 is equal to side H, 980, over sine of 114. Okay, then you just need to cross multiply and divide. So this is where I like to just have my variable on top because then I just need to multiply this up. So sine of 48 times 980 and divide by sine of 114. Okay, so I'm just going to type that into my calculator. So let's get this out of here. All right, so sine of 48, so going to functions, I've got 48 degrees, so I want it to be in degrees. So sine 48, whoops, that's just sine of 8. 48 times 980. Make sure that you have that 48 in parentheses. You've closed it. Times 980. And then divided by, whoops. Okay, I'm going to do it in two steps. So we're going to multiply those together. Then we're going to divide by sine. Oh, hold on. Let me show you what it's doing here. Okay. So I want to do the answer divided by. Okay, so answer divided by sine of 114. And you could literally type this in if you wanted to. I don't like to, so I like to hit answer. Okay, so then 797.2. Remember, this problem asked us to the nearest tenth of an inch, so to the nearest tenth. So that's a 0, so I would stay 2. So 797.2. And then inches. Okay, and now I like to think about this. So this angle is bigger than this one. So this side across from it should be bigger than the side across from this one. Okay, so it is. 980 is bigger than 797, so that's good. That'll catch some of your mistakes sometimes. All right, let's take a look at this one. So side R is 53 inches, angle S is 6 degrees, and angle T is 58 degrees. Okay, so S is 6 degrees, T is 58 degrees, and side R is 53 inches. So this is why I like to line them up like this. So for law of sines, you need an angle paired with a side. So you can kind of see here that you don't have an angle paired with a side directly. If you looked, 58 don't have it, 6 don't have it, 53 don't have it. But when you write it out like this, you can directly see, right? Like you don't have them, you don't have any paired like this. So I just think it's easier to see that when you write it out like this. So to use law of, but this is still a law of sines because we have two angles and then we have the side between it. So we need to use law of sines. So we need something paired up, okay? And so in this case, you're given two angles. So you know that the interior sum of a triangle is 180. So you're just going to do, take 180 and subtract off 58 and 6 to figure out that missing angle, which is 116. Okay, now you've got them paired up. So now which one are you trying to find? You're trying to find S. Okay, so we want to use this. We want to be looking for this side. Okay, so we're going to set up law of sines to be, and again, I like to put the one that I'm looking for on top. So since we're looking for a side, I'm going to do S on top over sine of angle S, okay, equals, now you can't use T because you don't have it. That would be two variables. So we're going to use R. So 53 over sine of 116. Okay, so I've got sides on top, angles on bottom. And again, I like to do that because then I'm just going to cross multiply and then divide. All right, so then we'll type that into the calculator here. So we've got sine, whoops, got to delete out the rest of this. All right, so sine of 6 times 53. Okay, and then you're going to hit enter. Then I'm going to do answer divided by sine of 116. Okay, and you get 6.16. And this one wanted nearest inch this time. Okay, so nearest whole number. Okay, so this one's going to be rounding to 6 since 1 is less than 5. So we'll stay down at 6. So for this one, we got S is equal to 6 inches. All right, then let's look at a couple that are going to be ambiguous, okay? So for this one, we've got side O, so across from angle O, side O is 100 inches. Q, side Q is 550 inches. And then angle Q is 67 degrees. Okay, so when we look at this, we have two sides, and the angle is not between those two sides. So this is an angle side case. So when I fill it in over here, we'll have angle Q, we will have side O, and then side Q. So looking at the picture here, you can see the angle side case. When you're writing it out like this, you also have two sides with a paired angle. So anytime you have the paired angle like this and two sides, this is going to be an ambiguous case. Okay, so let's take a look and set this up. Okay, so it starts just like normal. Okay, we're just going to have to check two cases. So what I like to do is just, I mean, on here, I can just duplicate it. Okay, and I write down a second case. Okay, because there's always a potential of a second triangle. So here's our first case. Here's our second case. The math starts out the same, okay? So we're going to start up here in the first case. We're going to set up our law of sines, okay? And so we're going to do, we're looking for this angle. So I'm going to do sine of angle O over side O, which is 100, equals sine of angle Q over side Q, okay? So this starts out exactly the same. Okay, so we will solve this. So we'll cross multiply and divide. Okay, this time that's going to be solving for sine of O. Okay, so not just O. So we get sine of O equals, so let's plug this into our calculator. So we'll do 100 times sine of 67. Okay, and then we'll take that answer divided by 550. So we get 0.1673, blah, blah, blah. So 0.1673. And so now that's for sine of O, right? So then we got to do sine inverse of that number. So I'm going to do sine inverse of the answer to get our actual angle measure. Okay, so 9.63. So angle O is equal to 9.63, and they want to the nearest degree. So O is equal to 10 degrees. So this is for our first case. Okay, right here, 10 degrees. So let's pause and look back here. Okay, so let's go back to the ambiguous case. So when we had this angle, okay, in this triangle versus this angle here in this triangle, this is kind of what we're doing. We're solving for this angle first. So remember, we want to find a relationship here, okay? We want to think about the relationship here. So if you look at this triangle over here, this with the red, this is an isosceles triangle. So the base angles are the same. So this angle right here is the exact same as this one. And then what's the relationship between these two? Well, they make a straight line. So these are 180. So whatever this angle is here, this one is 180 minus that. Okay, they always total 180 together. So if this one were 120, this one would be 60. If this one were 100, this one would be 80, and so on. Okay, so what we're going to do here is we've solved for the first one. Okay, so now if there happens to be a second case, this angle is going to be a linear pair or supplementary, sorry, not a linear pair, but supplementary with this one. So we will do 180 minus that angle to figure out this one, that second case one. Okay? And then you'll just decide, is this even possible or not? If it is, then you could continue on. Okay? It may not be possible. Okay? And how do we know if it's possible? Well, what do we know about the angles in a triangle? They need to total 180 degrees. So is it possible to have this one that was given 67 and this one at 170? That's not possible because that is way over 180 degrees already. Okay, and we haven't even done the third angle. So that means that this second case is not possible in this case. Okay, so this problem, that second case was not possible. So this is the only answer, the only triangle. Okay, so angle O is 10 degrees and that's it. No second case. So let's take a look at this one. So in this one, we have angle U, so side U is 740 inches, side T is 410, so U was 740, T was 410, and then angle T is 10 degrees. So again, looking at the way I've organized the information here, I have two sides with the paired up angle. So this is going to be an angle side case. You can also see this on the picture. You've got the two sides, and then that angle is not between the two sides. So you get that angle side case. So we are potentially going to have a second triangle. Okay, as we saw in the last one, there wasn't. It was only one case. So, but I still check it each time. So here's the first case, and then a possible second case. So let's go ahead and start. So we're looking for angle U. Okay, so angle U, so sine of angle U over side U for law of sines. And we've got this pair. So now we would do sine of angle T, which is 10, over side T, which is 410. Cross multiply and divide here to get sine of U. So go to your calculator, type in 740. So 740 times sine of 10. And then take that answer and divide it by 410. So this is sine of U, right? So this is 0.3134. And that's sine of U, so then we have to do sine inverse. of that answer to figure out the angle measure of 18.265, which they want the nearest degree, so we would say 18 degrees. So this first case has U at 18 degrees. So now we would go ahead and we would subtract that from 180 to get this one. So we would do 180 minus 18. Okay, and so 180 minus 18, and you're going to get 162 for this one. Okay, now is that possible? Okay, could we figure out a third angle that goes with this to equal 180? And we definitely could. So these three need to be total 180. Okay, well, 162 and 10 is only 172. That leaves 8 degrees left for this one. So this is possible. So the second case is possible. So there are two different answers. Okay, you could be 18 or 162. Both are totally fine.